Continuing on management decision tools discussion on integer and binary programming model. So here's a slide that is really nice because it summarizes a few tricks that we frequently use on models that contain binary variables. So for instance, oftentimes we'll be constraining the model to say that we need to pick k choices out of n possibilities. It can be as described here, choosing k projects out of n projects to take part in, to invest, to participate in, and so on and so forth, right? To work something out and then ignore the rest of the n minus k projects. So how can we describe that constraint? And that's easy, right? So if we have x1, x2, x3 to xn reflecting yes or no, taking part or not taking part in project I, then we just need to add up all the binary variables to be less than equal to k. So example, suppose n is 10 and k is 3, then, well, 10 is too many, maybe 5 and k is 3, then what we are writing on the summation symbol here is just x1 plus x2 plus x3 plus x4 plus x5 is less than equal to 3. That will be reflecting the desire to constrain it to at most choose at most 3 projects out of 5. Does it make sense? Yeah. What if we need at least? All right, so using the same example, if we are to choose at least 3 projects out of 5, so it could be 3, 4, or 5. Yes, you get it. It's basically just turning the sign. So you see that it's very important to write the sign carefully. So this is at most, right? And this is at least. Just tweak of a symbol changes the constraint, the meaning, and the solution immediately. So it's very consequential. Okay, what if we need to have exactness? What if we have situations where we say, you know what, we actually need to choose exactly 3 extracurricular activities to participate in out of 20, 3 at the most, because I have time for 3. We're encouraged to do 4, but I only have time for 3, so 3 is the most. Which 3? So if that's the case, then yes, you get the idea. We can modify from here and say that, well, it will be exactly equal to 3. Exactly k projects out of n choices to choose from. Yeah, okay, so it's very easy if we have gone through this discussion. And once you think about this example and try out on some other exercises, after a few times you get a hang of it. Once you hear the words, like I want at most 5 settings out of all possible 20 combinations. I want at most 4 different flavors on my ice cream, although I know you have 15 different flavors. So all these are beginning to trigger the sense that, oh yeah, I think I need to write it in this form. Okay, all right. So next is project J, that means xj, is conditional upon project I, and this is rather impactful. In other words, you choose project J. All right, you may or may not choose project J, depending on whether you choose project I. So I like to think about it as project I is dominant. That means if project I is not chosen, project J is definitely not chosen. But if project I is chosen, all right, then think about project J, because project J may or may not be chosen. So let's take a look at this. If xi equals to 0, then that means xj is less than or equal to 0. And remember that because xj is also non-negative, this implies that xj has to be 0. Yeah, okay, so that's correct. If we are not doing xi, then definitely don't think about xj. But if we are doing xi because solver somehow sets it to 1, then solver must consider xj because now xj is less than or equal to 1, and being binary means that we may or may not choose xj. So xj equals to 0 or 1. That's good, right? So give you an example to think about how this may relate to real life uh, applications. I'll give you a very simple but nevertheless pretty common sense example, and that is um, building a factory and building a warehouse. Okay, so I just write in short as I don't have a lot of space here, but please write something more meaningful. So xi is a binary variable. It's if it's 1, it means we should build a factory, and 0 otherwise. xj is that we will use additional funding, right, to build a warehouse. We'll build a warehouse, all right, but this warehouse is not for running a third-party business. It's to store the products, manufactured products for our factory. Now, obviously, if we don't build our factory, then we shouldn't be building this warehouse because it's not storing anything. Nothing is being produced. But if we should build a factory, then we have to think about the site. Can it contain a decent factory? Can the factory will the factory be too tall to exceed the building constraints, building limits, control limits? Do we have enough money, and so on and so forth, right? Do we have enough roads and so on? So we may consider building a warehouse, or we cannot because of other reasons, not because we build a factory. So in this case, we want to tie the connection between the two, all right? And the way to express it is building a factory is a main thing to consider. It's the dominant, decision variable. So something has to be less than or equal to the dominant decision variable, and that something is the decision to build a warehouse, and which is exactly taking this form. So the next time you encounter a situation like this, build a factory or build a warehouse for use by the factory, then you can think about this. So another quick example would be building a condominium. Should we consider building a garden? All right. So if finally we're not building a condominium project, then don't even have the garden because the garden is to serve residents for the condominium. But if we build a condominium, do we want to build a tall condominium, maybe at the expense of having a garden, or a lower condominium, but we have more resources, more capital, and so on and so forth to build a very, very nice landscaped garden, right? So the decision to build condominium, major one, the dominant one. So X garden less than equal to X condominium. Yeah. All right. So once we get a hang of it, we find that it's very expressive. It allows us to talk about if this, then that. If this condition is true, then that. Almost like programming the model without actually writing a program because it is not a sequential running of the constraints within solver, right? It's all carried out in simultaneous consideration. Good. Let's move on to co-requisite. So a decision of do project xi is co-requisite with decision to do project xj. If you do j, then you do I. If you do I, then you do j. If you do not do I, then you don't do j, and so on. Yeah, so that means they are the same decisions. And what that means is that xj is 1, xi is 1, and if xj is 0, xi is 0. Now, of course, the question is, why don't we just, delete one of the variable and just say that xi is a decision for doing project I and j. That if it's 1, then do both I and j. If it's 0, then don't do either one. And that understanding is correct, but maybe not always that extreme in some cases. That is to say that while the logic is correct, sometimes we do need two variables that need to be linked, connected, in the sense of putting them on the left and right side of the equal sign, such as this, right? The reason is that sometimes we think about having uh, two departments, right? The output of department A, right, has to be flowing at the same rate as the ability for department B to take in the inputs and then continue the processing, right? So you want the rate of output and rate of input to match. So if the decision variables of XA refers to the output rate, B refers to the input rate, they need to be forced equated with each other so that when we obtain the optimal solution, things will work out right. Instead of XA outputting a lot faster, a lot more than what Department B can absorb, then there'll be problem. So in that case, even though we describe output A and we describe output B, input of B, we want them to be kept separate and then having such a equal sign to force them to be having the same value. So that it is more expressive that output A is output A, input of B is input of B. Yeah, and then having the equality sign expresses our knowledgeable expression. We knew we did include this consideration that the output of A needs to be the same as input of B. So in those situations and many more, right, such as factory A output and the rate of processing ability, the capacity of factory B taking outputs from factory A, and so on and so forth, right? So many a times when A develops the model constraints, B develops the models and constraints, sometimes separately, sometimes over different timings or by different peoples, and then we need to integrate them. And then there's a need to, oh, your output needs to be the same as your input, connect them together like this. Okay. And finally, we have this also rather expressive case where projects I and J are mutually exclusive. So what does that mean? It means that when you do project I and J, right? So mutual exclusivity means that xi and xj are not allowed to be one simultaneously. That's all, right? So xi and xj can be 0, 0, okay, no problem. Do I, don't do j, that's okay. Do j, don't do I, that's okay. Do I and j together? No, that's not okay. All right. Now that's easy to try to talk about it in zeros and ones, but can we think of a useful situation? So again, I've given you the build factory, build warehouse, right? So I want to give you another simple situation, simple story to remember. Suppose the developer acquired a land, right? And the land is licensed, is permitted to be built with condominium or factory, right? So X condominium, it build condominium, all right, and X factory, build factory. So we ask, shall we build condominium or build factory? Building condominium, there may be a lot of profit. Building factory, we can sell it off fast and then therefore deploy our workers to build other factories or other projects. What should we do? What should we do, right? So we want to, amongst other things like budgets and workers and everything, we want to express the fact that, you know what, we only have one piece of land. You cannot build both condominium and factory even if you have money and factory and time and the license, right? So we want to say that the decision to build condominium and factory, they are mutually exclusive. All right, so you cannot have ones for both the decision variables. If XC and XF, they are either one is one, then which will mean that we build condominium, don't build factory, or that's okay, or we don't build condominium, build factory, which is okay. Is it okay if we don't do either one? We don't build condominium, don't build factory. In this case, answer is yes. Or rather, the optimal solution might be to just leave it because maybe it's too costly to develop it when the project is not selling well in this climate, maybe the COVID-19 climate, it's not selling well. So better don't build. Who knows, right? So it is permitted to not do anything. Both are zero, but it is not permitted to have both. That will be what we call mutual exclusivity.